Cool.
Um, so for all those people in attendance, I'd like to welcome you to the OpenStack Central Florida user group meeting. OpenStack Central Florida, as the name says, is focused on a open source software for building infrastructure as a service clouds. So the group focuses on building OpenStack, but we also do a lot with DevOps technologies as well. So for example, Ansible, Chef, we've had some presentations as well on SaltStack. So we kind of work on cloud, uh, particularly focused on OpenStack. We work on technologies that run on cloud, platform as a service, as in today's case with Cloud Foundry, and then we do a lot of work with DevOps. If you'd like to connect with us, you can join us with Slack. Just email me. My email is Donnie, DONNIEH, at OpenStackCFL.org. We have a Twitter, which is at OpenStack_CFL. And if you want to connect with us, we have a website. There's a link that's called Let's Talk off of our OpenStackCFL.org website, where you can connect with us. So you can get email or text messaging what we're doing. So that's the best ways to connect with us. Before we jump into it, I want to thank our sponsors, HostOn. HostOn, they provide us with free hosting of our community cloud. We're one of the few OpenStack groups that runs our own cloud. And we've been kind of heads down. We haven't done too much work since we got it up this time last year, but we're going to rebuild it shortly using Ansible. But that is big thanks to HostOn. They give us a lot of love and support. JetBrains gives us free software to share with our users. Primarily, most of the stuff we play with it relates to OpenStack is Python based. And then Stonington's Fried Shrimp, they support our events. So whenever we do events, they cater our food. So those are our sponsors. In fact, Stonington's just opened up a new restaurant. I can't remember where it is, but if you go to their site or check them out on Yelp, you can find information for the details.
I think it's up near Altamont somewhere.
Yeah, it's Altamont Springs. That's what it is. Yep, it's Altamont Springs. All right, thank you. Look at that. All right. So quick, who uses OpenStack? Really quickly, a bunch of people. It's used very heavily in enterprise for private cloud. So companies like Walmart use it, eBay, Volkswagen. They're doing some pretty incredible things with OpenStack. They found, I think with the OpenStack Summit, which is I think I attended in 2015 or 2016. I can't remember now. I think it was 2016. They made an announcement that something like, I believe it was something like 90% of the Fortune 100 or 200, some type of statistic, but a whole bunch of companies are running OpenStack. I can't remember what it is, and when I finally remember it, I'll be sure to share it out with the group. But it's very popular as a platform for cloud. There are a bunch of people who use it for public cloud as well. So some of the companies there are GoDaddy, Rackspace. They're the co-founders of OpenStack project. DreamHost as well as OVH. I believe OVH has one of the largest OpenStack public clouds in the world. And I think last year around this time, it wasn't even last year, it was earlier in the year. So this is October. Around April, OVH actually acquired VMware's cloud. So if you didn't know that, you should check them out for anything VMware related. They also use it for big data, so a lot of research institutes use OpenStack. And of course, the biggest users of OpenStack and the greatest champions of it are telcos. So they do a lot of work with OpenStack, and they really are pushing the edge when it comes to network function virtualization as it relates to OpenStack. If you don't know about it, they released a certification last year to become a certified OpenStack administrator. If you want to get up to speed on it, there are a bunch of places that provide online courses on it. One of them is Linux Academy. So if you want to get certified, you can definitely get certified on OpenStack now. That's good to know about. If you want more information on that certification, it's OpenStack. It's openstack.org/COA. So today's session is going to be on Cloud Foundry plus OpenStack. We are quite lucky today to have Chris Logan joining us. Chris Logan is a cloud architect for Cognizant, and he is a Cloud Foundry guru. I had the pleasure of meeting Chris at a meetup that he used to run some time ago. I think the last time you had your meetup running was 2 years ago, Chris.
Yeah, about that long ago.
It's been a while ago, but really, really valuable information. For those people who don't know it, Cloud Foundry is one of the major platform as a services in the market. I'd say the two biggest players in the space are OpenShift, which is provided by Red Hat, and then Cloud Foundry, which is open source. So there's a huge demand for the skills sets related to Cloud Foundry. Microsoft just released in their I can't think what it's called, but their Azure Stack. That's what it is. They just released with their Azure Stack technology, which is their private cloud technology, is that it supports Cloud Foundry, which is pretty big. So Cloud Foundry is very pervasive. It runs on a bunch of different clouds, including OpenStack. And the value of it, and I won't steal your thunder, Chris, but the value of it is that you can build on it, and once you build on it, your applications are portable, or have a certain level of portability to allow them to move to other Cloud Foundry platform as a service stacks running on n number of vendor clouds. So without further ado, Chris, I'll give it to you.
Absolutely. Thank you, Donnie. Appreciate that really kind introduction.
No problem.
Just give me 1 second. I'm going to bring up my, I have a deck I'm going to use to kind of guide through the conversation. But feel free, obviously this is informal, so feel free to jump in and ask whatever questions you want, whenever you want.
Cool.
All right. Bring it up right now. Okay, so if you let me know when you see my screen.
We can see your screen now.
All right, great. All right, so as Donnie said in my introduction, I work for Cognizant Technology Solutions. I'm definitely not going to give a pitch for Cognizant, but just to let you know that the Cloud Foundry skills really run the gamut from a lot of different companies, all the way from companies that are providing infrastructure, kind of like as Donnie said in his intro about OpenStack. It's the same with Cloud Foundry. Telcos are really involved in building their own versions of OpenStack, but it goes all the way to services companies like Cognizant. So at Cognizant, we're kind of known for outsourcing, but like all the other big consulting companies, we're getting into solutions, and so hence that's the connection to Cognizant. So a lot of people have different perspectives into what Cloud Foundry is. Some think about it as from a ops or infra perspective, which is very valid, but also there's definitely very much of a developer applications perspective as well, which is ultimately what it's trying to enable, and that's really where my focus is in the field and where my background is. All right, so a little bit of a history. Actually, Cloud Foundry has not been around that long. It came out of VMware because it really heavily relies upon virtualization along with containerization. It came out in 2011, and then to make it really useful, they created something called Bosch. So if you think about things like Ansible, Bosch is kind of Cloud Foundry's answer to that. So it's used to orchestrate the virtualization that IaaS basically the Cloud Foundry sits on. So it's really a pretty key aspect to it. And they instituted a governance organization around it so that it could be managed and developed throughout the industry, and also to promote its use. And that really accelerated the adoption of Cloud Foundry quite a bit. And now, as of this year, there are multiple companies that have their own commercial implementations of Cloud Foundry. I think Pivotal and IBM's are probably the two most popular. GE has theirs, but they sell it as their own product itself, not really a platform necessarily. And and that's really where a lot of customers have gone, is to the commercial version of it to get the support that they want. Although there's plenty of customers that dabble in the open source version as well. All right, so I wanted to position Cloud Foundry against these other types of solutions, and I'll try not to spend too much time on this stuff, but I think it helps in terms of kind of understanding where Cloud Foundry sits in terms of a technology platform. So really, if the value that you see in something like Cloud Foundry is that you get a full technology stack all the way up to the application level for whatever application you want to build. So you get standardization of your application runtime, as well as quick provisioning and configuration of it through a lot of different built-in tools and concepts of the platform. The big challenge for developers over the course of the past however long has been the challenge of provisioning infrastructure and configuring infrastructure, making it consistent, and things like infrastructure as code and DevOps, and a lot of that stuff has really helped. This is almost kind of a slightly different angle on it, where the platform itself, in a first-class way, understands all those things and is built into it. And of course, SaaS is, kind of at the totally other end. So the reason why a lot of customers want to be able to use a platform, use a technology like Cloud Foundry, and this is kind of a laundry list, but if you think about everything that it takes to deploy an application, and then to keep deploying that application, and then to scale it, and then to be able to manage it and debug it and all those things, Cloud Foundry essentially takes care of all those things within the platform, or it has connections to tools that can do that outside the platform. One of the ways it's described by some companies that sell it is it's kind of like application dial tone, which I think is kind of an interesting marketing way of putting it. But it's basically like you pick up the phone and you say, this is what I want, and you get it. So, and I'll talk a little bit about what the developer experience is, and describe it. You can kind of see that it is a pretty vast simplification against what developers have had to deal with traditionally, even in some fairly mature IaaS type environments. But I think that some of the interesting things here are, for example, around application portability. So because Cloud Foundry knows how to run an application, all you do from a developer's perspective is deploy, let's say, a jar file or a Python script, or let's say it's a Node application. You just deploy either a binary file or a directory, and it determines, to the best of its ability, how to run that application, and then builds all the entire runtime environment needed to do it. So if you're running it on OpenStack versus vSphere, it doesn't matter, because what you end up with is a container to run it. So it sounds a lot like the kind of Docker Kubernetes type model, and it is to a certain extent. The only difference is, in that model, typically developers are building containers, and then they're deploying those containers. In this case, developers are just building applications as they normally would, and without knowing about the containerization or runtime model. And then they're deploying that application, and the platform is taking care of the containerization. I think that's a big distinction between Cloud Foundry and like the Kubernetes Docker type model.
Redshift too, right? Because that's what Redshift does. Yep.
Yeah, exactly. So because, and one of those things is because I think firstly they have very different container models. They don't standardize on the same type of containers. I think there are commonalities between them, but they're not the same.
Okay.
And so so a lot of these benefits, quite frankly, are aimed more at developers, because ultimately the benefit of a platform like this is that developers can, within some boundaries, manage their own infrastructure and have tools within which they can configure their applications. And so that's really kind of, I think, the leap that Cloud Foundry promises. So here's kind of the next level down about what Cloud Foundry is. So if you start at the bottom, like there's your IaaS right there, and so there are a number of different IaaS that Cloud Foundry supports. Clearly OpenStack. That's why we're talking. That one of the first ones was VMware, so vSphere, but also it's supported by all of the major public clouds right now. And in fact, there's more and more announcements coming out about where it's supported in the public cloud. Some that are like less well known, like for example, like IBM's public cloud is one that's starting to be supported as well. And so above that, you have something called BOSH, which I described before. BOSH is the orchestration layer that exists that is actually doing things like provisioning VMs, configuring VMs, creating networks, allocating storage, doing all the things that you would need to do if you were orchestrating your infrastructure by through scripts. And at the same time, it has a layer that is specific to whatever IaaS or cloud that it's running on, and that's called the cloud provider interface. And then above that, it has the kind of the, if you want to call it, the public interface to that tools like Cloud Foundry use in order to be able to run. So then, if you kind of go up the next level, what you have is actually Cloud Foundry itself. And so within Cloud Foundry, really the most interesting things that are here within this are the, if you see where it says container scheduling.
Mm-hmm.
So within Cloud Foundry, what you have for your application is some number of VMs that you pre-configure as part of the application. Those VMs have a certain amount of resources allocated to them. And within that, Cloud Foundry will create containers within those that will run your applications. So it's kind of in the same way that Kubernetes does container scheduling. I'm not saying technically in the same way in terms of the same model. So you simply tell Cloud Foundry you want it to run your application. It finds a VM that has the capacity that you need in order to run it, and then it schedules the application to run there, and then through the dynamic router creates a path to that application. So if you deploy your application to, let's say, foo.cloudfoundry.org, internally it has that VM has an internal IP address with a dynamic port that then gets added to that router, so the router knows how to access the application that's located there, and it just keeps a map of everywhere where the application is deployed. So if you need to scale it, it simply replicates that application, spins it up in another container, and then adds it to the router. And then it has different routing algorithms it uses in order to be able to, usually it uses round robin, but I know that they've been looking at doing some of those things.
Chris, what type of container is it? I know there are different types of containers. So what type of container is it?
It uses Linux C groups.
Mm-hmm.
And that's the kind of the underlying technology for it. And then so basically what it's doing is it's doing process isolation that way. So within a Linux VM, you can have all these different applications running, and they'll have when you run, every application has a startup process, and that's basically where each one runs in a separate container.
Okay.
So they have isolation from each other. And so this concept of a build pack that you see kind of in the middle it's a set of scripts as well as some files that are used in order to turn the application from let's say, just because I'm a Java developer, I'll use Java as an example, from like a jar file into basically binaries that can be run in order to they will actually be run by the on the operating system in order to run the application. And so it takes, so for an example of Java, it detects, so it can automatically detect what type of application you have that's running. So it could say, oh, this is a Java application, or this is Python, or this is Go, Ruby, whatever. Takes the appropriate files it needs in order to run it and bundles it together with the application you've actually deployed, and creates basically a startup script. Mm-hmm. And then all of that is packaged together in what's called a droplet. and that droplet is stored in what you see. It's called the blob storage. So that when you have to scale the application, it can scale very quickly. It just grabs it out of the blob store and then starts it back up again. And so it takes all of that, deploys it to the container, and then runs it, and then binds it to the port on the VM, and then moves that, and then makes that available through the router. And so now your application is running. So that's kind of the basic life cycle of how an application runs and how Cloud Foundry supports that. Underlying all that, so let's say you have 5 VMs that run applications for you. There's at least another 20 that do all these other things related to scheduling, security, routing, blob storage. So there's a typical Cloud Foundry installation usually has at least about 25 VMs associated with it.
Okay.
Only a small subset of those are actually running applications, depending upon how big your installation is.
Now, when you say VMs, do those VMs have to be physical nodes, or can those VMs be VMs?
No, they're actually VMs. So what happens is when you first install Cloud Foundry, there's kind of a bootstrapping mechanism you have to do where you have to you first create you install basically a bootstrap VM into the IaaS, and then you start it, and then there's a web application that runs on it. And when you do that with the right permissions, it goes and creates, I'm trying to use the right terminology for OpenStack, but creates template VMs.
Okay.
And then those, in the terminology calls them stem cells.
Stem cells?
Yeah, I know, everyone laughs because it is kind of an amusing term. So it uses those to create all the new VMs from it. So there are no physical machines in this. They're all VMs.
Okay.
And then on the right, you'll see this thing that says it's a cloud controller. So the cloud controller is a REST API that's made available primarily for development type operations. It basically allows you to do everything. There's a CLI that sits in front of that cloud controller API that most developers would use to do things like deploy applications and all that type of stuff. But it actually allows you to do a lot more than that, things like monitor applications and see logs and stuff like that.
What's this all written in? What's the platform as a service? What language is it written in? Java or?
Yeah, that's a great question. So no, it's not. It's slowly being moved over to Go.
Okay.
Originally, a lot of it was written in Ruby, but I think they found that they preferred Go. I think that, so when I talked a little bit before about it being an open source system, it is true, but there are only really a few major contributors to it, of which I think Pivotal is probably one of the main ones. And so their choice was to switch over to Go, and so that's slowly what they've been doing.
Yeah, I heard Go's from a language perspective is better for, microarchitectures. It's better for services and much faster, more efficient than the Rubies and Pythons of that.
Yeah. Oh, sorry. Go ahead.
I was done. That was a statement.
Oh no, I thought I heard someone else say something.
No, I was saying it's probably better for system programming right now. It's Go takes on a lot of the networking stuff, and system programming, things are going in that direction. Docker's written in Go, Kubernetes is written in Go, so forth.
You are really low.
Sorry about that.
Heard you, but it was a bit low. So, yeah, exactly. And I think that's the reason why they're doing that. And I think that they've generally been pretty happy about that decision so far. So the other thing underlying all this is the fact that the system tends to operate like a black box. So from a networking perspective, from a networking perspective, when Cloud Foundry gets installed, it can either be installed in a routable or non-routable network, which is going to determine how you need to access it. And most customers, quite frankly, install them in private networks. They install them within a private network so that you have to use something like a jump box to be able to access it and to do like administration type operations.
Okay.
But within that, you have very little access to the VMs themselves because all of the passwords, the account names and passwords are generated dynamically, and they're stored in before they were stored just in manifest files, but now they're being stored in basically like a some type of repository, like ID storage mechanism. I'm not sure exactly the implementation. And so you, as an administrator, and certainly as a developer, the system is meant to be treated, I'll say, like a black box. So, for example, if you're used to doing things like installing intrusion detection or different types of monitoring tools in your infrastructure, you would not do that in Cloud Foundry for a couple different reasons. One, at any point in time, a VM can be destroyed and recreated from the stem cell, and so anything that you did would be lost when you do that. And secondly, the pitch is that they're constantly doing patches to it that are going to address things like security issues and things like that. And at the same time, they can't really say that installation of such tools wouldn't create problems with whatever they have installed on that. I think that some of that is true and some of it is probably not true. But in general, you would never, unless you're troubleshooting something at the lowest level, which I've done, but it's not a very pleasant experience, you typically would not be interacting with the system at a VM level. You would be interacting with it in one of two ways, either through the Cloud Foundry API, which is the cloud controller, or through the Bosch API, which is implemented or runs on a machine that's not shown here, but it's called the Bosch Director. It's basically a VM that sits there and is kind of the key orchestrator to everything that's running in the IaaS. And so you would not do things like SSH into boxes and install software or make changes, things like that. Now, having said that, there are some occasions when you have to do that, but actually Cloud Foundry provides a way to do that where you get actually like a temporary password or a key, and then you use an API to be able to basically create a session for yourself to SSH into a box. So it's not something that you administer on a VM level. You kind of administer it as an overall system. And I think that makes it a little bit different.
How do you collect troubleshooting information? So if you have an app that's not functioning the way you want it to function, how would you track them? I'm sure it has to have some type of monitoring APIs in it. Yeah. Performance monitoring.
I'm testing a new pointer right now. So
it looks good, by the way. It's highlighting logging and everything else is great. It's pretty cool.
So if you see this component here, it's logging. There are really two levels of logging that are done within the system. The first is at the system level. Every VM has logging capability. It has a logging agent, and all of that is collected into a big system log. And then most organizations will, you can configure within Cloud Foundry basically what's a log drain. So a lot of companies would use like Splunk, or they would do their own. Like kind of custom open source type logging system. So that's at the platform level. So for example, if you want to see what happened on this particular VM that may have caused it to crash, if you're trying to troubleshoot things like that, then or if you're doing installation, then you can see it that way. Then at the application level, there is a separate application log drain that you can use. That you can also do the same thing. So you can log to same type of tools. So the idea is that as a developer, if I want to troubleshoot, I would no longer go to the VM and start tailing the log or connect to the application server or whatever and see the log file. Instead, it's all drained to one central place. And so that I would use the tools available in something like Splunk to be able to see that. And they've introduced features like correlation IDs and things like that, so you can see how a transaction is running through the system across multiple requests or across multiple VMs. Remembering that sometimes one operation could invoke multiple services, application services within it. So.
And then I have another question. So you build, you take your app, you release it into You release it in the Cloud Foundry. It provisions containers out. It figures out how the app's supposed to scale. What if I want my app to speak to another app? Would I just have to use some type of REST API to have it communicate with something else, or would there be a special way I can speed up communications within the Cloud Foundry environment to other Cloud Foundry apps in there? Is there some type of I don't want to call it a messaging bus, but almost a registration service where apps can register to speak to each other?
Yeah, there is not something that is kind of special to Cloud Foundry. Really, if you had something, so the short answer to the question is no.
Okay.
The longer answer is, yeah, you would use the same mechanisms that you'd use if you were running it in any other PaaS or in any other architecture, really. You would use REST APIs or asynchronous like messaging to be able to communicate. Or you might use things like discovery servers, like Eureka or something like that, in order to be able to facilitate them finding each other. The difference is that I think they've tried to make it so that you don't always have to go out of the system and come back in, which was something that was done in earlier versions, so that there was networking latency involved in it. So they've tried to change some of that so that you can keep all the networking internal during during a series of calls instead of having to round trip back out. But,
so your dynamic router would be intelligent enough to figure that out?
Yeah, it's going to look and see what the destination is and see if it's something that it could route it to or try to resolve it, and then instead of sending it back up to the network that it's connected to, it would try to handle it internally. I don't know if there's what all the special cases might be for that, but that's kind of the general idea behind it. All right. So I talked a little bit about Bosch. So if you look here, here down here at the bottom is your IaaS, and then what you have is you have your cloud provider interface, and again that is the part of Bosch that is specific to whatever IaaS you're running running Cloud Foundry in, and then you have Bosch here. Bosch is an acronym that I don't know why they did this, but it's kind of self-referencing. It stands for Bosch Outer Shell. So it doesn't really mean anything at all. But I think one of the key things to understand is that Cloud Foundry is not just Bosch. Or rather, Bosch is not just Cloud Foundry. So Cloud Foundry is one, but probably most popular piece of software that Bosch runs. Because ultimately, all Bosch is doing is when you first install Cloud Foundry, the first thing you do is you install Bosch, and then after that you install Cloud Foundry within Bosch. And when you're installing it, basically you're telling Bosch, I need 25 VMs, and they need to look like this with these resources, and then I need to have these. This software running on each of them, and you basically it's a specification for VMs that you want to be able to run, and then Bosch creates them, manages them, and does things like keeps them up and running, performs health checks on them, destroys them and creates new ones when it needs to, things like that. So Cloud Foundry is not the only thing that can run within Bosch. So for example, there are some other products, like there's Hadoop implementations that run on Bosch. There are other types of there's other pieces of software, like for example, there's like things like Jenkins and other types of CI/CD tools that customers have built deployments for. And so what that's called is a Bosch deployment. And really what it is, it's most basic is a manifest file that specifies a bunch of VMs that you want to create. And so Cloud Foundry is probably one of the most popular ones and probably the biggest Bosch distribution that's out there. But I've seen companies build custom Bosch distributions to do things that they just need a separate, they want to be able to run in a managed way, and they want to keep it all within Cloud Foundry. So they decided to create something custom for themselves to be able, like I know one customer did something like that to do this kind of special type of log aggregation that they wanted to do. And the first thought was, well, we'll run it in a VM in our IaaS. And then, we thought about it and said, well, that doesn't make sense because now all of a sudden you're running something that can't be managed or has the same, SLAs as we had running within Bosch. So we created a separate Bosch distribution. And so then, sitting above Cloud Foundry would be your applications. So, the applications are run and managed by Cloud Foundry.
Cool.
All right. So, at one more level of Bosch, and I think that Bosch is really the part that most ops guys, infrastructure guys want to understand because it's really the thing that kind of lies at the core of how, incomparable to something like, Kubernetes. So here you have whatever API is used to communicate to your IaaS, and you have this Bosch director VM, and within that director VM, you have this CPI, which is the machine that's going to talk to your IaaS, and then you've got basically this registry of all the machines that you have running within the system, as well as a blob store that's used to store any images that you need. And so what's happening is that when Bosch first starts up, the director CPI is asked to go create all these VMs, which are over here on the right. Every VM has this Bosch agent on it, and that Bosch agent is how Bosch manages that VM. And so these agents are publishing things. They all have things like health endpoints and different types of monitoring endpoints that are made available to them through the Bosch agent. And they are reporting data back through NATS. So NATS is an internal messaging technology that's used to communicate things like health status. So all of the time, Bosch can be sitting there looking at the health of these VMs to see how they're doing, if they're performing well or if they have any issues, and they need to be destroyed and recreated. And so within Cloud Foundry, for example, all the VMs that Cloud Foundry creates are examples of these Bosch managed VMs.
Is that Bosch DB there? Is it a special type of database unique to Bosch, or is it running something like a MySQL or
it's MySQL, but it's not something that you can control or even really look at.
Okay.
Yeah, it's using things like storing the states of certain VMs and things like that. I'm not sure exactly how it differentiates from the registry, but all of these things are ones that are created internally. So when you deploy it, you, for example, wouldn't need to provision a database outside of this infrastructure.
So do you define, when you are setting up Bosch, do you define where what VMs or containers these services live in, or do you just let Bosch do it? Do you just tell Bosch these are the specs for the environment I'm creating? It goes and does it wherever it wants to.
Yeah. So really, all you're going to do is you're going to tell it when you first go to install Bosch. You basically tell it your within your IaaS what like resource pool or whatever I'm not sure what the right OpenStack terminology would be, but basically where to go find the resources that it's going to use to run it. And then from there, and then as I said, you created a VM already. You just have to make sure that the account that it's running has the rights to go manage your IaaS. And then from there, it just goes in. So it's going to go and it's going to create all the VMs it needs from that stem cell. And it's going to install the software on it that it needs to install. And then it's going to do a bunch of checks from like a networking perspective to make sure that that it's configured properly. And then at that point, you have basically an up and running version of Bosch. And then from there, you can go install like Cloud Foundry.
So for us, from the OpenStack side, if it's creating VMs, it would speak to Nova. If it's doing stuff with networking, it's going to talk to Neutron. If it's doing stuff with images, God, I forgot what the image store for OpenStack is. I'm ashamed. I think it's Cinder.
I think you're right.
I think it's Cinder is the image store. So those are those services. It's going to be primarily and then it's going to do Keystone for all the security because everything has to have secure communication. So I thought you were going to play some music for us.
Yeah. I can do that too. You want a soundtrack?
Thought you were going to give us some cool tunes to do this too. All right, so I see how it connects through, and then it uses its own container technology on top of the VMs to isolate everything and control. Okay.
Yeah, exactly.
Cool.
Oops. This one now. Right, exactly. So as we get further, I'm going to start talking about kind of what the process looks like for doing an installation on OpenStack. But as I said before, it's kind of a long process. And actually, I think that if we wanted to have a different kind of session, or maybe do it in pieces, like maybe prepare the environment first and maybe get to a certain point, it might be interesting still to do it. But I think there's a lot of waiting around that occurs.
Okay. Like, how long does the installation take, would you say?
So there's a bunch of steps that you do at the beginning to get Bosch up and running, and that can take about maybe 20 minutes, and then you're going to wait while it finishes installation, because it has to go provision all the VMs, and so that can take, depending upon whether there's other things going on in the infra, it can take maybe 20 minutes as well. And then when you go to install Cloud Foundry, it's also pretty quick. You make all the configurations that you need to make, but then literally it can take like an hour to install it after that.
So it's like a 3-hour window to prep and install the software.
Yeah, I've spent days installing it before, because you run into a problem like with networking, and then you have to start all over again, because as a system, it doesn't like to be fussed with once it's installed. So it relies upon all these manifest files, and you can't really go in and start editing them. You have to go through these processes where after you make a change, you have to kind of rerun different processes to get the manifest files to take effect. So, but it still might be interesting to go through the process sometime.
Okay.
So
I think we have enough psychos in a part of the user group who would do it.
Yeah.
All right.
It's sort of a learning experience, I have to say that. So as I said before, this is some of the popular private cloud or IaaS that is supported by Cloud Foundry. So you see that like a lot of companies internally, depending upon what kind of shop they are, will either run it like on VMware or run it on OpenStack. But many of those are starting to look at how they would run it on public cloud as well. And AWS was really the first one. And then Azure, which you mentioned at the beginning, Donnie, is now supports Cloud Foundry. And then finally, and Google Cloud is now supporting it. And what this means by supporting it means, if you remember before I talked about the Bosch CPIs, it means that there is a Bosch CPI for those public clouds. And so it follows the same model where you go in and you install the director VM, the Bosch director VM, and then it has the CPI for that cloud, and then that goes and knows how to go and create all the VMs and manage them already. And so this is a key part of the portability aspect that was referenced early on, because portability is a really nice concept, but is actually a lot harder to achieve from an application perspective than what it sounds sometimes. And so from a Docker perspective, the way Docker achieves portability is you've got the Docker runtime installed everywhere. And so if you create a Docker image, then wherever you have the Docker runtime, you can theoretically run your application. Cloud Foundry takes a slightly different approach. And in that approach, if you want to have application portability, you write your application the way that you normally would, but you're going to have some constructs like there's not APIs, but there's things like deployment manifests and resource bindings and things like that. So if I want to, if my application needs to use a database, there's a way that I can bind my application to the database so that the application has the credentials and the URL needed to connect to it, for example. And so then I would install Cloud Foundry in all of the clouds in which I would want to run my application. So let's say I had public and private, and let's say I use OpenStack and AWS. I would install Cloud Foundry locally and however many OpenStack installations I needed for things like DR and high availability. And then I would do the same thing in my public cloud. And then you would use kind of a multi-cloud deployment topology to figure out where to deploy your application, and use things like global load balancers to figure out, like, things like, is it active-active or active-passive, and how to handle things like failover, and then you could utilize, for example, things like heartbeat health checks on your on the router. I don't know if you remember the dynamic router from the other slide. Let's say your whole system went down on your private cloud. You could do kind of an active-active failover. It really wouldn't even be a failover at that point. Maybe you just route all of your traffic to the public cloud at that point, if that was a model that you were using. But in that case, what you do is you would deploy, every time you deploy an application, you would deploy to both.
Okay.
Or let's say another example that's probably more common would be, let's say I have a main site and a secondary site, and what would have typically been DR, but now let's say I'm just going to call it like site A and site B, and I deploy my application to both when I deploy it, and I would use like a data grid behind the scenes. So when I write a transaction in my application in site A, it will sync to the database that's in site B. So that means that my traffic can basically go to either system, or I can put off the traffic to site A, and if site A goes down, I can then just move over to site B fairly seamlessly, and I probably would never really lose transactions, or very few of them, but there's always that kind of latency of how long it takes for transactions to catch up before site B comes up.
So let me ask you a question.
Uh-huh.
So you're telling me that I could basically set up an environment where I run Cloud Foundry on OpenStack internally in my environment. I have another installation in AWS. I have another installation that runs in Google Cloud Compute. And then I could configure it so my application is intelligent enough to distribute to all of them and do failovers to each cloud depending upon different scenarios.
So let me break it down a little bit. So you first part, yes, you would install Cloud Foundry in those different clouds, and then you would then use, let's say, for example, in a deployment tool, let's say, for example, if you use something like Jenkins to manage your deployments, you would decide where you want to deploy your application. So, for example, let's say I want to make sure I have high availability across data centers. So I can install it in multiple data centers. Let's say that I want my application to have high availability across private and public cloud, which is kind of the example you were giving. So let's say, for example, I use AWS as my as like a failover, which may or may not be the best way to do it. But so I would deploy my application to both. So my Cloud Foundry that's running on my private cloud and my public cloud, they don't know anything about each other.
Okay.
And so what I have to do is I have to deploy my application to both, independently from each other. So when I do it, let's say my developers have a new release of their software, and normally they would just deploy it to my private cloud. Now they would set up their release mechanisms to deploy to both. And that works great, and that's all you really have to do if your application is totally stateless and let's say doesn't store any data. Let's say it's just a pass-through to other things, to other services. That's all you really need to do. But let's say, for example, that your application is like a system of record. Let's say, for example, you're building like a reservation system and you have to have a database that sits behind it to keep track of it. Then you would need to synchronize that data because you don't want your public cloud instance of the application having to go back to your private cloud database because of the latency associated with it. So then you would have to solve that like in your data tier by doing things like data synchronization in the back end using, there's various database technologies that you can use to do that. I mean, things like Oracle do it, but there's other things like Cassandra and databases like that you can use to accomplish that as well. And so now instead of having active-passive, I can now do active-active, and because it's really easy to tune the application from a scalability standpoint, So let's say, for example, I say, wow, I'm getting a huge load on my servers right now. I don't know why, but I can just say, I can just use the CFCLI to go, okay, I want to bump this application from 2 instances to 5 instances, and you'll have those 5 instances up and running like within a minute. And then they can start handling traffic. And then once you see the traffic go down, you can bring them back down. So you could do the same thing, presumably, across those public and private clouds. But at that point, you have to have something like a global load balancer that's going to be routing traffic between them so you can take advantage of it.
That's pretty slick. Okay. Quick question for you: Who makes global load balancers? Like, who would you go to for a solution like a global load balancer?
I think like Cisco. I think we do it. The question is where it fits in your WAN. I think.
Like an F5 or something like that.
F5, yeah, exactly.
Okay. Yeah, I was thinking F5, but I wasn't sure. All right.
Yeah. All right. So just to kind of give you an idea of some of the customers that are using Cloud Foundry, they tend to fall into a lot of banks and a lot of insurance companies. I've worked with some of these companies myself, and I'd say the exception to that would be, by the way, Verizon, who is a big open source Cloud Foundry customer. Actually, in Florida too, they have a big development center in Tampa, and then Walgreens as well, which is kind of is slightly different from the rest of these from an industry perspective. So the main there's two ways to look at the motivation of why companies use a technology like Cloud Foundry. One is a very infrastructure operations perspective, which is things like operational efficiency, scalability, reliability, all that stuff under one pane of glass, right? So I can aggregate all these things I want under one product, and I can easily do things like I want to scale my application, I want to monitor my application, I want to be able to give more resources to my application, and I can do it all within one platform, which makes it easier to administer. However, that's not the real selling point of the software. The real selling point is the fact that for companies that need to be able to have faster time to market due to things like disruptive competitors or business cycles accelerating or the need to get into new markets faster, things like that, the idea is that it removes the traditional barriers that have been created between development and operations teams, where they say, oh, you need a VM? Okay, submit a ticket, and we'll get back to you in a week, and you'll get your VM, or how much memory do you need? And it's like, you have to etch it in stone how much memory you need on your VM, even though developers usually have no idea what they need. And so the idea is that instead you basically remove those barriers, and now developers are in direct control of the infrastructure that they need using the Cloud Foundry constructs that are made available. And so the idea is that now the costs and the time needed to experiment, if you will, from a business perspective, have been greatly reduced. And so it accelerates the time to market for new things. So I'll give you an example would be companies like Allstate have been able to, if you see they've been advertising a lot lately, they have really embraced this new development model. They're really the poster child for Cloud Foundry, quite frankly. If you were to Google it, you would see that there's all kinds of case studies about them, about how they've been able to accelerate their time to market for new products. I think one of the case studies is they wanted to be able to offer motorcycle insurance, and they needed to develop this new software to be able to new applications in order to be able to manage that and do all of that. And they're able to do it much faster than they were ever able to do it before because of a combination of using Cloud Foundry as a platform as a service. They adopted a DevOps type model for how they integrated their teams. They used things like Agile, and then they went to some new. They started adopting application architecture patterns like microservices to be able to do that. So those are really the four pillars that are driving this industry right now. And I would say that, and actually, I think that it's not really pillars. I think that you would put Cloud Foundry kind of at the bottom. It's kind of the thing that supports the rest of it, because without it, you can go like so fast, but then your infrastructure is going to stop you from being able to go faster. All right. There's a bunch of companies that are involved in the Cloud Foundry Foundation. So if you see, Pivotal is really the one that's driving a lot of it. IBM has their own flavor of it that they've developed that runs in the cloud. Cisco and SAP, I think, have been involved in developing their own versions of it. VMware is looking at basically making a next generation version of their vSphere ESXi products that support containers natively, so that you no longer provision VMs, but you provision containers directly. I'm not even sure what that's going to require them to do at that level, but the idea is that they're kind of fully embracing it. And, Pivotal and VMware are all part of Dell EMC as an umbrella company. So,
Pivotal's underneath Dell. I didn't know that.
Yeah, so Pivotal was founded in 2013. Mm-hmm. So I worked for Pivotal for a while, actually, and then I worked for Dell EMC. I worked for EMC, and then they got bought by Dell, and then I left. But originally, what were all the Pivotal technologies were within VMware and within EMC, and they weren't really they weren't really being managed all that well within them, so they decided to spin them out into a separate portfolio. And then if you look down here, like Huawei has their own version of Cloud Foundry that they sell as a platform to telecommunications companies, that they sell as a telecommunications company to their customers. So, for example, I'm a Huawei customer. Basically, it's like they're selling the platform to their customers.
I have a question for you. How do you do billing with it? So, like, if you deploy this and you're trying to figure out how you're going to do stuff like chargeback, is there some type of mechanism that would help you with billing in the system, or do you have to get something and plug it into Cloud Foundry?
What happens is that within Cloud Foundry, there's a concept called an organization, and so it really depends how you want to do that. But a lot of times, for example, an organization could be like a line of business. So, for example, it could be like private banking, public banking, commercial banking, whatever banking. Those could each be lines of business within your finance company, and those would be organizations. And then with that, you have something called a space, and the space is basically a subdivision where you can do things like dev, test, QA, production. That's one way to do it, a simplified way of doing it. At that organization level, you can specify quotas, and at that space level, you can specify quotas to say there is a certain amount of total memory utilization that cannot be exceeded by this entire organization. And within that, you can generate reports that's going to show you, and so basically it's like gigabytes of memory per hour is basically the way that the reports work. But basically it's going to give you all this information about how many applications are running, how much memory they're using, how much storage they were using, because there's storage associated with those VMs from an application perspective that can be looked at. And so all that's made available, and then what most companies that I've dealt with do something more of like a showback type model.
Right, typical showback.
Yeah, and so that you have these reporting mechanisms that you can use, that you can generate to give back to them. I think that they're building things into the Cloud Controller API that lets you kind of automatically generate those things. So if you want to build, there's not kind of a first class like billing capability built into it. You can automatically do really cool things to generate bills, but the basic data is there, and you can generate reports off of it. It's just a matter of kind of how you need to distribute that, and and all the back stuff. Yeah.
So, other question is there like aside from deploying it, like how hard is it to build an app on it? Like, could we go someplace and build a little Hello World app and deploy it to see what the experience would be like?
Yeah, so the best way to do it is this. So go to if you go to run.pivotal.io, This is something, it's called Pivotal Web Services. So as I said, Pivotal is a commercial version of Cloud Foundry. They call it Pivotal Cloud Foundry. Pivotal Web Services is a cloud version of it's running on AWS version of Pivotal Cloud Foundry. And so you can go here and create a trial account for 30 days.
Okay.
And then it's you're billed only by active applications. So if after that you want to pay for it, it's really pretty cheap. What you have to remember to do is stop your application. So if you toy with an application, because you get charged only for the time it's running, and by the amount of memory it consumes. So I've gotten bills for like $5 and things like that. So what this allows you to do is you can then this is a little bit of kind of a sample of what the screen looks like. So for example, I'll talk about orgs and then spaces within it. And so when you go to Pivotal Cloud Foundry, Pivotal Web Services, you're going to get this dashboard. It's going to allow you to manage the orgs. So you're going to get an org. Basically, that's what you're leasing from them, if you will. By the way, if you look over here, see it has things like this is kind of an idea of the billing. That gives you kind of an idea of the quota.
Okay.
So you can say, okay, I have a 10 gigabyte quota. Once that quota is exceeded or met, no one can deploy any applications within that org anymore.
Can you do things like approvals? Like, does it have like the capability if someone deploys an app that it has to be approved by somebody, and then once the approvals is done, they're allowed to deploy?
No, typically there's not. Typically the way that's handled instead is in like lower environments, you would only allocate the amount of space that you wanted, like for things like developers to use, and that would be kind of small, but you would give it to a broader audience. But once you get up to environments that you want to have more control over, what most companies do is they don't allow individuals to deploy to those. Instead, what they have is like a non-person ID, like a system type ID, and only tools like a Jenkins or a deployment pipeline type tool can actually do a deployment to those environments. And that way, so approvals are done within a tool like that.
Right. Okay. So they leave it to like a Jenkins or a Travis or something like that.
Yeah, exactly. And they push it into that. And so exactly. Yeah. So that's a more common way that it's done.
Interesting. So you kind of you put this in place so you don't have to worry about anything with infrastructure, and then you front end it. You say whatever build process that we're using, CI, Travis, Jenkins, you guys use this. It will push it to the environment, and then you can just go look at your app on the web. Done.
Yeah, exactly. So
wow.
Yeah. So for example, this is CFCLI right here. So this is a training system that we have access to. So if I run this, I need to log in. So what I can do is I can run these commands like CF apps, and it's going to tell me all the applications that are running there. I can do things like CF push to push an application. So there's really kind of two experiences for the developer. One is this CLI, and then the other is this application manager interface. So when you go into Pivotal Web Services, and once you install it and get it up and running, you then there's a page that tells you how to get started with using the CFCLI. Like you can use things like Brew to install it, and then once you get it installed, you can any application that it can run. And I think out of the box, Pivotal Web Services will run Java, Python, Ruby, Go, Node. It will run static things like HTML. I think that those are the popular ones. I might have missed a couple, but and then you kind of experiment with the CF push thing, and it basically pushes your application, which means that it runs it, and what you get back is a URL that it's running at and that you can access that.
Now,
That's
question.
what's called Cloud.
I know that for Platform as a Service, part of Platform as a Service, it has messaging, it has database. What kind of databases, like how does the database interaction work with this platform as a service?
Yeah, that's a good question. So, here, let me see if my count is still coming. Okay, yeah, good. Yeah, exactly. So, so if you look here, I have this space here that's called development, and within that, I have my application here. So if I go back up to the org, and I go to something called the marketplace, well, you have it. These are all things that I can install into my org that are basically services. So one is, for example, a MySQL database.
Okay.
So I can install, if I click on this, what you see is I have 4 different tiers of this MySQL database. And so by the way, these services in this marketplace are another example of Bosch deployments. So they are running, when I install this MySQL database, in general, the MySQL database is a Bosch deployment that's running within, like next to Cloud Foundry. The difference is that when I'm provisioning this, usually when I'm provisioning is something like a schema or a database. I'm not necessarily provisioning like an entirely new Bosch deployment. So I would say, well, which version of it do I want? Okay, I'll just take this free version here. So I select that. I give it a name. And kind of tell it what space I want to. And then what I can do is I can say, what application do I want to bind it to?
Okay.
So I can say, I want to bind it to this application, Hello Spring Boot REST. And I say add. Yeah, I'm not authorized. But basically what happens is, when you do that, when the binding to the database, so for example, like the database URL and the credentials that are needed to access it, are injected into the application through whatever that technology is that's appropriate. So for Java, it's going to make it available to the system properties of the application. So now, as an application developer, I can now just go look at the system properties, and I can get back what's the binding URL, what's the URL to bind to my to this database that I have. So if I change databases, I don't have to change my code, because all I'm doing is going to that system property and retrieving that information. So if I instead bind to another instance of it, my application doesn't care. It's transparent to my application. So I can use this. I can use this marketplace to provision things like databases. Here's RabbitMQ. Here's one like a centralized configuration server. So most companies, what they'll do is, here's another example, like a New Relic, if I want to do like monitoring. That's really more of like a broker to like the New Relic in the cloud. But basically, this is how you get the rest of the as a service part, so messaging as a service, or like database as a service. And so what you can do is, once you, in your manifest files and all the ways that you script the creation of applications, you can specify the services that you need to create, as well as how they're connected to each other. So you can say, my application demo app is bound to this database, and so at runtime it injects the information into the application that it needs.
It automatically creates it. I got you. So it sets up the connection string dynamically for you, and you don't have to worry about it.
Exactly. And it also runs the infrastructure needed to be able to manage things like the MySQL database. So in this case, MySQL will be running within Bosch.
So hence, Bosch knows how to orchestrate and scale it as required.
Yeah, exactly, because the Bosch manifest tells Bosch, for example, this is how many of this I need, this is how it needs to be scaled, things like that. So it's kind of basically, it's telling Bosch how to run it.
All right.
Yeah. Okay. So from a developer perspective, what this looks like is, so as a developer, I just do something called CF push, which is a command, and I push whatever, a directory or a binary or whatever. And then what it does is it calls this thing called a cloud controller, which is a REST API, which basically tells it to create an app what that does is it stores the application metadata in this internal database, and then uploads the files to a blob store, and then starts the application. From there, the application then attempts to do something called staging, where it converts it from like a jar file into a droplet, which is the fully formed application that I need. And then it stores that droplet in this blob store. And then it finds what's called a DEA, which is basically a VM that can run an application. It finds one, copies the application over to it, and tells it to start it. And then that DEA then goes back to the cloud controller and says, okay, I'm started, this is where I'm running, this is VM, and this is the port that I'm running it on. And then it updates, and then that's basically what the router you're using in order to be able to know how to route to the application. So the key thing about this is, all the developer really does is CF push in the most simplified view of it. And what they get back is where the application is running.
And that's why the developer looks so happy with his arms wide open and he can't even make an expression.
Yeah, exactly. Yeah, you got it. And within that CF push, you can tell it how many instances you want to run, how much memory you want them to take, how much storage you want them to have, and Cloud Foundry just takes care of making that happen. So
developers must be very challenged with that because they want all the memory, all the storage. That must be the hard part.
You can set limits on the maximums actually, so that they can't go crazy with it. And because it's fairly easily policed because you've got, let's say, like for example, like the development lead or maybe some manager, we'll call it a lead, can see all that too. And so it's not like you can go create a VM and then no one in the development team can see what you did because it's hidden behind some IaaS management pane of glass. They can see it themselves. So
quick.
Yeah.
Oh no, I was gonna say in regards to the visibility with everybody being able to see it. When it does the push, is there any tuning of the code that's done by Cloud Foundry? So when it gets the file or the jar file, or if it gets the Python, the PY file, does it look as it changes that code into what Cloud Foundry is going to run? Does it do some type of optimization against the code to make it run as efficiently as possible? So I'm basically asking, can you take crappy coders and through the platform turn them into superstars?
No, it doesn't do that. It's crap code in, crap code out. Unfortunately, there's a little bit of optimization that occurs if you're doing Java development with the Spring framework, which is pretty popular in enterprise software development, because it's really, I think Java with Spring is like the most popular runtime for a lot of applications running on Cloud Foundry. At least that was their target because of the close relationship between the Spring project and the guys that created Cloud Foundry. And so if you push an application that uses things like Spring Boot, it will automatically do some configurations to your application to make it run better, but it has nothing to do with any of the functionality of the code.
All right. So garbage in, garbage out. Okay.
Yeah, unfortunately. So I think one thing that comes up a lot is why you would use Cloud Foundry versus Kubernetes. It's not a sales pitch necessarily, but this didn't come out as clear as I wanted. But one of the things I think that you'll see on this is that in general, Cloud Foundry has a lot more people committing against it over time, and also tends to has more steady commitment level. I think that's because of the commercial support that it gets. And so, for example, you'll see like all-time commits to Cloud Foundry is like 100,000, whereas all-time commits to Kubernetes is 39,000. So I think I think that's kind of I think this is kind of an interesting chart because it kind of says what's the activity and how are they being maintained. But I think that the real thing here is there aren't a lot of customers who use what I would call open source Cloud Foundry. And so I think as a comparison, it tends to lend itself. Open source Cloud Foundry and open source Kubernetes tend to be kind of similar to each other. A lot of companies use commercial versions of Cloud Foundry like Pivotals. And so from that perspective, really what you're talking about is it's a buy versus build. So do you want to have to manage all of your components for container scheduling, and then all for service discovery, and for all of these different things, and you have to be able to have like 20 different technologies that you have to get to work together. Whereas particularly under the commercial implementations of Cloud Foundry, they've tried to pull all these things under that one umbrella so that you get a product, a more fully formed product that you can just go install and configure through a single pane of glass. The difference is that you're going to pay for it because Cloud Foundry, Pivotal Cloud Foundry is not cheap at all.
I would imagine that most enterprise customers, if they had to choose between Cloud Foundry and Kube, they would go with Cloud Foundry because it's support. So they're going to get phenomenal support, and they can police what their guys are doing, and it's simple for a developer just to go and get something up and running. I could see them going to the supported option. You know.
They do, but the companies that make commercial versions of Cloud Foundry have really figured out how to make money off of it. So you don't pay licenses for. Actually, you do pay a one-time license for each implementation. They call it a foundation of Cloud Foundry. So let's say I have like 3 of them. One for test, one for Prod A, and one for Prod B, let's say. So that's 3 of them, and I have to pay a license fee for each of those at one time. But then I also have to pay an application instance subscription. And so you buy those in packs, like for example from Pivotal, you buy those in packs of 50 instances. So let's say I deploy an application, I want to run it 3 times for high availability and performance. That's 3 of those 50. And so a pack of 50 is in the tens of thousands of dollars. And so if you do your math, it starts to add up really quickly. You can get to millions of dollars in subscription fees easily per year. So then all of a sudden, big customers will have to look at it and go, okay, compare that against just hiring people.
Gotcha. Now, the other question I have in terms of that whole pricing model, does that subscription include the underlying cloud IIS that you're running on?
No.
So you have to pay the Cloud Foundry and then whatever it costs to consume the underlying infrastructure as a service. Ooh, okay.
Yeah, service is just software subscription.
Gotcha. All right.
Yeah. That's why it's not a no-brainer as much as it sounds like it, because you're paying for all of that. And part of it's because the commercial versions of Cloud Foundry have built tools on top of it that make it a lot easier to manage. So out of the box Cloud Foundry, you're using either the Bosch CLI or you're using the CF CLI, the Cloud Foundry CLI, to do everything. You don't have any web interfaces or management tools, and some of the other tools are not available to you. When you buy a commercial implementation of it, you get web interfaces on top of it that make it a lot easier, so you're not going in like hand modifying YAML files and things like that.
Okay.
So, all right, so I think I talked about this, kind of how Bosch works with OpenStack. You got the CPI. CPI knows how to do things against that cloud, like starting and stopping VMs, etc. And you have these stem cells that it puts in the IaaS or into OpenStack, and then uses those to create VMs. And so with any system, the way you get started with any IaaS flavor, the way you get started with it is, first there's a fair amount of environment setup that you have to do in order to get the system ready for it. And then you deploy Bosch. And then once you have Bosch, then Cloud Foundry is a Bosch deployment that you install within it. And so there is a fair amount of validation you have to do of your OpenStack environment. So, for example, you have to verify access to your OpenStack API endpoint. You have to be able to access the metadata service. You have to be able to do things like validating that your access is set up correctly by attempting to like ping between machines. And then be able to do things like mount storage. There's a kind of long list of things that you have to be able to do to validate that your OpenStack instance is ready to be installed on. And then you then have to create a security group because there's a lot of networking egress that occurs at the beginning of it when it's first starting to do the installs to validate. It has, in some cases, it's actually downloading software through that, as well as it needs to be able to talk to other VMs. When you install Bosch, the Bosch managed VMs separate from Cloud Foundry can be installed within separate private networks from each other. So what I learned, I was never strong from a networking perspective, but I became a lot stronger by going through the process of installing Cloud Foundry several times, because there are some nuances from a networking perspective about what it does in terms of how it isolates networks from each other. And so a lot of the problems you run into when you're installing Cloud Foundry, quite frankly, are almost all related to networking. Either DNS or things like the machine that kind of sits between them is oftentimes like multi-homed, and then there's challenges with things like what network interface it uses to connect between networks. And so some of those things may have been resolved as they got better, but I know that those were a lot of the challenges that we had early on installing Cloud Foundry. And then you have to be able to set up DNS because you have these fixed endpoints. So let's say you call your you have to have some static IP addresses for the endpoint machines, the ones that sit on the periphery of your Bosch managed network or your Cloud Foundry network. Those have to be accessible from outside. So you have to set that up within DNS. And then finally, you have to be able to validate that you have certain resources available within OpenStack. So certain types of machines with certain amount of space associated with each of them, and it's going to try to provision those as part of it. There's a lot of documentation about this too, by the way. That's why I didn't kind of get into that to the level below this. And then once you do that, then you have to be able to actually prepare. Once you have the environment ready, you're about to deploy Bosch, then you have to go create these key pairs that you're going to use for security, and then create more security groups, and then finally, once you get to that point, then you're going to deploy Bosch. So there's a bunch of, I think that's most of that stuff is kind of fairly OpenStack specific. And then you create something, you install something called micro Bosch, which then is used to install Bosch. So it's basically like a bootstrap of installing Bosch. And then what Bosch is going to do is it's going to create all those VMs I showed you before. And then at that point, then you will then have a fully running Bosch implementation that you can then use to deploy Cloud Foundry. And then finally, when it comes to installing Cloud Foundry, you're going to download the Cloud Foundry bits and then go in and make changes to the Cloud Foundry deployment manifest that is going to basically specify things like what's the wildcard DNS you're going to use for applications, different types of how many VMs you want for certain things. You can tune things like you can say, I want every VM that runs an application to have this much memory. SMTP addresses. There's a bunch of different stuff that you configure. So one comparison between open source and commercial Cloud Foundry is that commercial Cloud Foundry provides a web app to do all of this stuff. So, but basically you're going to go in and make all these changes, and then underlyingly what it does is it uses the Bosch CLI to do a Bosch deployment of Cloud Foundry into Bosch, which then creates all the VMs for you. And then what you get at the end is you have the cloud controller running that you can then use the CFCLI to start talking to be able to deploy applications.
It's like an Inception.
It is, yeah, it is. It feels a little painful, quite frankly, getting it set up. And I will say that it's As a technology, it can be a bit finicky. Like I will say one thing is that it's difficult to take down, to quiesce. There's not really a documented way that I've seen that you can take the system down easily. So we used to install like on a fairly beefy Mac Pro, and then move that Mac Pro around. And whenever we tried to like shut it down, it just didn't want to start back up very well. Because it's really not meant to be run that way. So I would say that if it's something once you get it set up, it's not something you want to power down regularly. So be prepared to have the resources being utilized most of the time.
Quick question for your deployment manifest: is it a deployment manifest a single file, or is it multiple config files?
It's a good question. Early versions were one big file, which created a lot of challenges. One, because it was gigantic, and two, because there wasn't a logical separation of things that you would likely change and things that would be specific to different environments. In the newer versions, they've separated into multiple files that are split out logically, and so it makes it easier to understand what you're changing. I think now I think there are three separate manifest files for Cloud Foundry.
Okay.
And you can do things like if you change a manifest file, you can use Bosh to be able to apply those changes. So you can change an already running instance and have it take effect.
So Bosh is critical for that. Okay.
Yeah. So that's Cloud Foundry in a nutshell.
Chris, thank you very much. That was awesome presentation, man. I really, really appreciate it.
My pleasure. I'd love to be able to come to you guys in person sometime, or be able to do another talk about it. As I said, I'm kind of I'm more of a developer than an infrastructure guy, but this is an area that I'm fairly passionate about in the last couple of years. So we'd love to keep coming to these meetings, and especially if you're going to have them, if you ever have them virtually.
Yeah, oh yeah. What we're gonna try to do is that it's been hard to coordinate, so we're gonna try to do more meetings virtually, and then try to do a face-to-face meeting every other month. So that's our goal. Like we're gonna have another meeting on I think it's November 7th. A guy who's part of the user group by the name of Luke's going to come out, and he's going to talk to us about Ansible Tower. So I have to look at the exact date. I think it's November 6th or November 7th that's going to happen. It's going to November 7th, and it's a Friday night. But I will be there Friday night nerding out. It's going to be really cool.
Sounds great.
It's going to be hosted at HostDom. So HostDom's hosting it. Should be fairly cool. Chris, we'd love to have you back. If I can hunt you down and I can coordinate my schedule with yours, would love to get some more insight on how to actually configure and set up Bosh. And in the meantime, I'll probably go to the site and just play around with it. I think it'd probably be informational for me to just go to the site and get a free trial and play around with it. See what it feels like.
Yeah, for sure. Yeah, my pleasure. I'm glad that we were finally able to make this happen.
Excellent. Thank you so much. Could you give me remote control just one more time? I just want to talk to the guys and show them my deck. All right. I now have the power. I have the power. So, again, Chris, thank you so much. Great presentation. For those people who are watching, if you're not aware of it, OpenStack Summit is taking place in Sydney. So you should go to the OpenStack.org website and get some details on it. We have a few of our members who will actually be going to Sydney OpenStack, and they will be presenting on us. But they'll be presenting sometime in November. Maria, as a matter of fact, is going to be going from our OpenStack user group, and she's going to come back and give a summary of the summit in late November. I think it's the 18th, but I have to check the exact date. Thank you guys. Thank you guys for coming out. You know, as all of you know, I'm a technology nerd, and I love new developments in technology. And I appreciate all the users who participate and give their time and kind of share this passion with me. So look out for us. Go to the OpenStack Meetup page to find out what our next meeting will be. And then you should let me know, send me an email if you want to join our OpenStack Slack channel. Just a good way for us to communicate and stay in touch with each other. We've been pretty kind of low key as a group since I believe April of this year, because I've been completely overwhelmed with work. But we'll be picking up, the OpenStack Central Florida group will be picking up and doing a lot more sessions. And for those people who can't attend, we'll try to record it and post it up on our YouTube site. All right, Chris, thank you so much. Members, thank you so much. If you guys need to get in contact with me, my contact information is there. Awesome. Thank you.
Thanks, Donnie.
Thank you, Chris.
Yep.
Thanks. Appreciate it.